A homing device left its home to deliver a message. On takeoff, the device encountered a tailwind of 9 miles per hour and made the delivery in 5 minutes. The return trip into the wind took 10 minutes. How fast could the device fly in still air? Alright, so we are asked to find the speed of the device in still air. So let's let our variable x equal the speed of the device in still air. So we're going to say speed of device in still air. All right, now we're told that on takeoff, the device encountered a tailwind of 9 miles per hour. So the device's speed would increase based on that 9 miles per hour. So when it's going into the tailwind, it's going to be x plus 9. And when it's going against the wind, the speed is going to be x minus 9 to account for going against the wind. All right, now because we're dealing in terms of miles per hour, our time must be given in hours. So we need to convert the 5 minutes to hours. And in order to do this, we're going to say 5 minutes is equal to 5 over 60, and thus it's equal to 1 over 12. And our 10 minutes is going to be equal to 10 over 60, and thus 1/6. So at this point, we're going to set up our table. We're going to have with the tailwind and going into the wind. Or in other words, going against the wind. So I could erase the against the wind and refer to that actually as into the wind. All right, now let's set up our table. We've got our rate, we've got our time, and we've got our distance, just like every other table we've set up so far. So when we're going with the tailwind, we said that our speed, our rate of speed would be x plus 9. And when we go against it, it's going to be x minus 9. Our time with a tailwind, we were told, is 5 minutes, and thus that converts to 1 over 12 hours. And our time going into the wind was 10 minutes, which we said converted to 1 over 6 hours. Now recall once again that our distance is going to be equal to rate times time. So that means I've got 1/12 times x plus 9 and 1/6 times x minus 9. Now keep in mind that your total distance traveled going with a tailwind is going to be equal to the distance going into the wind. So we're going to set these distances equal to each other. So I have 1 over 12 times x plus 9 is equal to 1 over 6 times x minus 9. Now, because we don't want to deal with fractions, we're going to multiply both sides by the least common denominator. So I'm going to multiply both sides of this equation by 12. When I do this, these 12s cancel out, so I'm left with x plus 9. When I multiply this side by 12, I see that 6 goes into 12 2 times, so I'm left on this side with 2 times x minus 9. Add this point, I'm going to distribute the 2 so I can drop my parentheses. This gives me x plus 9 is equal to 2x minus 18. I subtract x from both sides, so that gives me 9 is equal to x minus 18. And I add 18 to both sides, which gives me x is equal to 27. So I can see here that my speed in still air would be 27 miles per hour.